Heisenberg Uncertainty Principle. In 1927, a German physicist named as Werner Heisenberg proposed a principle, and that principle is actually called as Heisenberg Uncertainty Principle. Now, as we know that there are two kind of theories, quantum and classical. Some scientists propose classical theories, but that classical theories have some flaws that classical theories are unable to explain the facts and figures involved in the microscopic objects, say for example an electron. So that's why scientists comes up with new theories, and that new theories lies in the quantum theory. Now Heisenberg uncertainty principle is one of them. So having said that, what is Heisenberg uncertainty principle? Heisenberg uncertainty principle states that it is possible to measure or calculate exactly both the position and momentum of an object. Say, for example, if you have any microscopic object like an electron, we are unable to measure the position and the momentum of that electron at the same time. And Heisenberg uncertainty principle is based on the wave-particle duality of matter. So at first, let's learn what is wave-particle duality of matter, and then we will discuss how it affects on Heisenberg uncertainty principle. As we know that there is dual nature of light. Light can act as a wave also, and it can act as a particle too. Now, how light can act as a wave? We know if any beam of light strikes with the surface, it reflects back. So, this reflection proves that there is a wave nature of the photons or the light or the beam of the light. On the other hand, we say that a light has also a particle nature. For this, say for example, we have a surface of metal here. There are a lot of electrons there. Now, what happens here that if a photon comes here and we strike the photon here on the surface of the metal, it will eject an electron from the surface of the metal. So this ejection of the electron proves that photon has particle nature too. Why this photon has particle nature? Because this photon has some momentum. This photon will transfer its momentum to this electron, and position of the electron will change, and the electron will eject from the surface of the metal with some velocity. So this is actually the dual nature of the light. Now let's discuss the Heisenberg uncertainty principle. Say for example, here we have a surface of a metal. So here we have a lot of electrons. Now what happens here if we have a photon and that photon will hit or strike this surface of the metal? Because in the change of momentum from this photon to this electron will eject from here and go there. Now, if I want to find out the position and momentum of this electron, we know that the speed of electron is equal to the speed of the light. Now, because the speed of electron is equal to the speed of the light, when this photon will strike on the surface of the metal, abruptly I will find out the position of this electron. If I am done with finding out the position of the electron, because the speed of the electron is equal to the speed of the light, this electron will abruptly change its momentum. I am done with noting down the position, but at that point, I am unable to find out the momentum. In the other scenario, if I want to find out the momentum at first, what will happen here that when this photon will strike on this surface of the metal and electron will eject it from here, I quickly noted down the momentum of this electron, but due to this fact that the speed of the electron is equal to the speed of the light, this electron will abruptly change its position, that this time I am unable to note it down the position. So you can see here that if I am able to find out the momentum, I am unable to note it down the position because of the speed of the electron. And if I am able to find out the position at the same time, I am unable to find out the momentum. So it is possible to find out the position and momentum of any electron or any microscopic object at the same time. So this is what Heisenberg uncertainty principle is. Now here we have the formula and application of Heisenberg uncertainty principle. At first, let's talk about the formula of Heisenberg uncertainty principle here. This is the changing position, this is the changing momentum, and the position and momentum is greater than or equal to h by 4 pi. Here this h is equal to Planck's constant, and we know that Planck's constant value is 10 raised per minus 34, which is a very small value. So error in the momentum and error in the position should be greater than and equal to this value. These two are actually inversely proportional. Why? Because if we are finding out the position, so this is multiplying here. When it goes to the other side, it will times here. So of course this position and momentum is inversely proportional. We can write this formula in this way too, where momentum is equal to mass and velocity. Here, if we are bothering an atom, so we know that the mass of the atom is constant. The thing that is creating difference here is the velocity. So here the velocity will go on the other side of the equal, and it's inversely proportional to this position. Why we learn this uncertainty principle, and what are the applications of this Heisenberg uncertainty principle? Actually, we know that according to Bohr's, or according to the Bohr's atomic model, he said that electrons move in a circular orbit around the nucleus in an atom. But we just came to know that we are unable to find out the position and momentum of any microscopic object at the same time. So it means this postulate of Bohr's atomic model, that electrons revolve around the nucleus in circular orbit, is totally wrong. So this Heisenberg uncertainty principle is there to prove that the postulate of Bohr's atomic model is not correct, and after that some other models tell about the probability that we are unable to find out the exact position of the electron in an atom, but yes, we can tell the probability. So yes, this is all about Heisenberg uncertainty principle. If you want more such videos, please don't forget to subscribe. Thank you very much.